Hi, I'm Tim McConnell, Director of Engineering at 3D Robotics here in San Diego. And I'm here to talk about these. And probably if I ask everyone in here what this is, everyone will come up with something else. It's a UAV, it's a UAS, it's a drone, it's an RPAV. Lots of different names that you've all seen in the news recently, but you have seen these in the news recently. It's really the kind of the bleeding edge of what's happening out there, and it's lots of fun. Fun technology to develop and a lot of fun capabilities. We develop drones here in San Diego and build them in Tijuana, Mexico. And I'll tell you a little bit about the company, where we came from, what types of things we build, all the different areas where these things are used, and areas where we think they're going, where we hope they're going, where people besides us will determine that they're going, and you can use your own creativity to think about what that means for the world going forward. So our company's been around for about 6 years. Chris Anderson was the editor-in-chief of Wired magazine, but his real love was to go out and play with toys. He loves to tinker and build stuff. So he decided that he wanted to get his kids fired up about robotics. He bought a Lego Mindstorm. He built a little autopilot. He said, he always jokes that his kids by the end of the project said, "Dad, we have no interest in this," but he was having great fun. And he built the world's first autopilot for a small remote vehicle. And it actually, that plane now hangs in the Lego Museum in Denmark. In parallel with that, a young gentleman from around here, he actually grew up in Ensenada. His name's Jordi Munoz. And he was here in the States waiting for his green card application and trying to think of something interesting to do. So he was sitting at home and he was playing with some remote control vehicles, and he was playing with a Wii, and he thought, I turn my Wii controller and it knows what I'm doing, how I'm doing it. What if I took out some of the electronics and stuck them into, wired them up in an airplane? Could I get the airplane to know what it was doing? So he pulled apart a Wii controller and took out some of the devices in there, wired something up, and basically created an autopilot that would fly in his plane. Some of his friends saw it. They said, "Make one of those for me, Jordi." So he started making these. He built a little a reflow oven out of a toaster oven he bought at Walmart, where he basically took out the thermostat and controlled it electronically, and he was building little boards that way. Well, Jordi and Chris met at an event, and they both realized this was a match made in heaven. Jordi had the skills and the electronic experience and joy of it. Chris had all the connections and the kind of the grand oversight of thinking about big companies, and said, let's make a company out of this thing. So they built 3D Robotics. And it's been growing pretty steadily since then. We're pretty much doubling every year in what we build and what we sell. The picture over on the lower left was the manufacturing facility that we built here in San Diego. Made all of our electronics, autopilots, and devices there. Eventually it got so large that we teamed up with a fella in Mexico, in Tijuana, who built a factory there, which now operates with about 100 people, cranking out drones and autopilots. We were all down there yesterday. Our office is in Otay Mesa. The factory is 5 miles away in TJ, so we just go back and forth across the border, and it's a terrific symbiosis. So we have 4 offices: engineering here in San Diego, manufacturing in TJ. Our headquarters is in Berkeley, and then marketing and video production in Austin. So growing company, a lot of good things happening there. The evolution of our technology started out with the ArduPilot, which was the first autopilot that someone made on a little Arduino platform, and it's grown steadily since then. It's open source technology, so there's developers all over the world that contribute to the technology that runs on here, both the hardware design as well as the software that runs on the autopilot, and other pieces of software we have running, for example, in the ground station that send the control messages to the autopilot. The development community are all connected by a group called DIY Drones. It was founded by Chris Anderson. 54,000 users on there. You can read all the rest, but a whole lot of people. So I'm going to answer one of your questions early, Tony, about how people can get engaged in this. Great place to start. Go look at DIYdrones.com. There's stories about the drone industry. There's tremendous links to other places. There's wikis. There's FAQs. Everything you'd want to know, just either to learn about the technology or to learn how to make them and get engaged in it on your own. We just created a website a few months ago called Drone Share. And it's a way for people in the community to be able to share their flights and their flight data. One of the really fun things about this technology is it's so new, and there are so many people inventing it, and there's so many things we're learning on a regular basis. And the more interaction and the more connection you can have with the whole community, the more quickly you can learn and grow the technology. So once you get far enough along, you've been to DIY drones, you decided you want to get your own iris, which you can get off our website, and start flying, then you can get yourself an account on DroneShare, and you can start loading up your flights. So you can go out and fly down at the RC field, and then look later on, and you'll see your flight there on DroneShare, and people can go see what happened and look at your log data and make lots of determinations about how things are going there.
How about regulation?
I'm sorry?
How about regulation from government?
Oh, we'll get to that. Yeah, excellent question. We'll get to that. So interestingly enough, sort of related to that, this is a flight that was taken in Australia where the regulations are quite a bit different. It was taken in Ballarat where one of our best developers lives. He's a 3D Robotics employee that happens to live in Australia. So the advantages of open innovation, I'm not sure how many people have worked in an open source environment. This is my first foray into it, and it seemed like a strange thing to me to work for a company that thinks it's somehow going to make money by doing open source. But we're doing pretty well at it. It's got some wonderful advantages. The technology moves so quickly. People always ask me, do you have IP? How do you protect this? And our answer is, we just go so fast that we're keeping ahead of the competition, and it's worked really well so far, and that's really the model we're building on. There's no regulatory barriers because it's just all shared and open on the internet. I mean, there's not really rules for the internet, so everyone can share all the technology and share all the source code, and it's sort of a self-regulating thing. That natural business model is something that Chris Anderson came up with, give away the bits and sell the atoms. So the idea is that you sell something like this, you sell a piece of hardware that you build better than anybody else, but all the software that runs on there is free. The application, you hook this up, and anytime there's new software, you can just go download it. The software that runs on your phone or tablet to control it is all free. Development, a lot of it is done by the consumers, and it leads to high innovation. So these are the most typical type of aircraft that we have. The one on the top left is the Iris, just like this. Then there's an X8 next to that, which is shaped like an X and has 8 motor propeller combinations, and a Y6 down below that. You can figure out the math. And a fixed wing over on the right side. And the fixed wing aircraft and the copter use essentially the same technology. It's the exact same autopilot that drives them both, and you can put the autopilot on a ground vehicle as well. Operates the same way. Just very quickly, here's how I got there. Started out doing a bachelor's thesis in school. Got lured out to San Diego to work for the Linkabit Corporation, which most of you aren't old enough to know but it's the foundation of any high-tech communication company in San Diego. They all stem back to Linkabit, which was formed in the late 70s. Same guys that started Qualcomm, a couple of guys named Viterbi and Jacobs. They came out here and taught at UCSD and then formed Linkabit together. Then a little company called AP Labs, Dr. Design, Vision Robotics, where we made giant robots for agricultural applications, Solikai Systems, and finally here I am at 3D Robotics. So this is one of the cool applications that runs on the Iris that's can be downloadable. There's a button on your phone called Follow, which you'll see. He's just sticking his little phone with an antenna under his shorts, but you can also just have that in a backpack and have a Pebble watch and just push the Follow button. He's not flying the airplane. He's not even telling the airplane what to do. He just pushed Follow, and he started running. And all this video is being taken by an Iris that's following him around. So it's a super advanced leap to getting people to be able to have this technology in their hands. All of a sudden, you've gone in a few years span from people like Grant over here, who's going to fly for you later, who's a great expert with RC and can do anything with an RC copter, to now people like me, who aren't experts at that, but just want to have the thing fly around and take cool video. So I can put it in follow me mode, or I can put it in a mode, and there's a one-button mapping mode. I can point to a house on a GPS and say, or I'm sorry, on a Google map. I can point to my house and say map, and it'll do a few loops around my house, take a bunch of pictures. We can stitch those pictures together into a 3D map. Ton of other applications that can be used for these. I won't spend too much time in going into those, but you could sit here with a your friend and a pitcher of beer and think about the crazy things you could do with this stuff and all the great technology that's going to happen over the next 10 years. And mark my words, it's going to be incredible things, some of which are happening right now. There's guys in Africa that are protecting rhinos and elephants using drones to track poachers and to track herds and things. Folks in Australia using them to track their cattle. I mean, there's a ton of great things, tracking, rainforest, mapping of those things. There's all sorts of environmental response. If there's a spill or some sort of disaster, if you think of a place where you really wouldn't want to put people or you couldn't get people easily, for example, think of the Fukushima nuclear disaster. They don't want people wandering around in there, but if you could send a drone in with video and Geiger counters and things, you can learn a bunch of great things, mining disasters, things like that. Police departments are really interested, search and rescue, first response. Construction, it's a great thing to be able to map a building and watch as it grows. And of course, sports photography is where probably most of you have seen applications so far. So the start of this technology is really in the consumer space. These things are available, people are getting them, there's really great stuff happening. And it's so popular and prevalent because regulation is pretty light on what you can do with one of these. I can take one of these out and, well, I can't fly it outside here because I'm right under the takeoff path for Miramar, but most places you can go out and fly it around and there's no restrictions. But once the FAA gets a little more kind of on top of how they're going to regulate it, enterprise space is what's really going to drive innovation. And we'll talk about the FAA a little more after we talk about some of these potential applications. So agriculture is a great one. It's one of the easiest ones to do right away. Farmers will tell you that they go out and walk around and look at crops, look at fruit on trees, or look at the edge of a field that they can't get into and try to make assessments of how a huge crop is doing based on a small amount of visual inspection. Well, now we're taking drones and we're flying over in sort of a repeated pattern over crops and fields where we can get pictures of every single plant out there, and we could do it every single day. And you can watch over the course of time and see what parts of the crop are doing better or worse, where you might need to water more, where there might be some sort of infestation. So farmers are thrilled about this. 3D mapping I talked about. This is the Fry's electronics store up in San Jose. We did the one-button mapping operation with that and created, these are two different views of the 3D map, the 3D model that we made of this Fry's store. So great for, for real estate, also for construction. You could take one of these 3D models and overlay it over your original plans and see how something is growing and being built up. Some of the other applications that I'd like to talk about are, infrastructure, inspection, and determining where there are issues. So in the United States, there are 63,000 bridges that are considered structurally deficient. That's from the US Department of Transportation. And for those, it's about 21,000 that are considered fracture critical. And those aren't nice words to hear when you're thinking about being one of the 2 million vehicles driving over these things every day. So how do you know which ones you want to fix? There's just all sorts of problems out there, and how do you know what's going on? Well, you want to inspect them. Right now they inspect with big giant machines and people on them. You can imagine how hard it is to get that machine in place, how long it takes to train somebody to use it. They probably had to shut down half the traffic on that bridge just to get it out there. Or you can send this guy out crawling underneath them all. And that's probably not the most efficient. Or this guy can go up with his jetpack and look at them. But do we need to inspect them? Obviously we do. Nobody wants to see pictures like these. What if we could have determined that those were the bridges that really needed the attention? So what's a better way to inspect? It's not just bridges. There's 2 million miles of pipelines in the US, 140,000 miles of railroad tracks, 2.7 million miles of power lines, including SDG&E has 26,000 miles of them through some 450,000 trees. I just met with some folks from SDG&E a couple of days ago. They said they have 4 helicopters. They fly all 4 of them pretty much all day, every day. And the least expensive of those to fly is $1,200 an hour. The most expensive is $1,800 an hour. So do the math on what they're spending to inspect their power lines. So there's, helicopter inspections, or guys that aren't maybe quite so efficient as a helicopter walking down the track. Pipeline, if you're not inspecting, that's what happens. So how can we do it more efficiently? Well, of course, the answer is let's do it with drones. You know, let's take some drones, put cameras on them, program them to go fly underneath the bridge, get all the video, get all the pictures, and then of course we can process those and determine really what needs more attention. You know, power lines, obviously it's going to be a lot safer to have that thing flying around a power line than a full-size helicopter. So you can put these drones anywhere. You can, you know, they're somewhat expendable. I mean, this thing's a $750 device. You know, if you lose one of those, it's not like losing a human flying a helicopter. So you put them out there and you can do all sorts of inspection. And these are all the things that 3D Robotics builds. So it's probably a good time to address your question about regulation. So regulations are different everywhere, and unfortunately they're probably more strict here in the US than just about anywhere. You know, the FAA has deemed it very important to restrict all commercial activity with drones until they can get regulations in place that they feel address the safety issues most importantly. So right now in the US, you can't fly any drone for commercial purposes. So
Even smaller?
nothing. So when you see a realtor that says, here's the drone view of this house, you know, they're being quiet about it and everything, but that's against the law. And they really can't do any of those things. So we're waiting, and there's a lot of pressure on the FAA, and there's a lot of people involved with it and trying to, you know, help them move it forward. There's been a commitment to have some sort of regulation in place by the end of next year. Fingers crossed, we'll see how well that goes. But there's a lot of complexity involved in trying to do it right. So we have to wait to some degree right now before we can get things out. Now there are ways to get around some of the regulation. There are exemptions that you can get from the government to be able to fly in certain areas and do certain things. Some of the larger infrastructure companies are getting access to exemptions where they can have an area. You know, if you want to fly over a pipeline out in a remote area, it's probably not nearly so dangerous as, you know, someone out, you know, flying around with a keg of beer underneath their drone in the middle of a city. So they can get an exemption to go to inspection, and we're working with some of those companies to help, you know, advance the ball on some of these industrial applications. But it's very slow moving until there's, you know, more clear regulation there. Australia has much looser regulations. That's why you saw that Google is doing their test of package delivery in Australia, which is unfortunate for us.
How about military applications? Like I can envision easily Ukraine, for example, right? And how to prove that Putin does send his army to Ukraine.
Yeah, so this is perfect. And this is why you and I need to get a pitcher of beer, and we're going to sit down and think of all these great things. Obviously, there's a ton of military applications. I mean, the biggest military drone companies are here in San Diego, right? Northrop Grumman, General Atomics, British Aerospace. Those are the big drone companies, and they've been doing great stuff for the military for a long time. That's way over on this end of the spectrum. Commercial stuff that we're doing is over here. There's a big gap in between, but eventually they're going to kind of move closer together, where you have smaller drones that are doing, you know, more close inspection, and where these types of drones become, you know, more authorized to do things and more capable of doing things.
But military applications are not regulated by anyone at this time.
You know, I'm certainly not that familiar with exactly what the structure and regulation of those things. I mean, I'm sure there's quite strict regulation on how they do things, and probably very strong safety standards. And I've got some guys that work for me who have done a lot of work in that area. We have not, as a company, been anywhere close to that field, so I can't really delve into some of the details on that. Okay. Oh, I should have stepped ahead before talking about that. So there's lots of robotic activity happening in San Diego today. It's really the center of drone development of anywhere. And then there's a lot of other robotics companies that are really advancing the ball quite a bit. Qualcomm Snapdragon processor is really well suited for a lot of drone activity. It's got a huge amount of processing on a very small amount of mass and power. Snapdragon talks about teraflops per gram. You know, the amount of processing they can put into a tiny package, which is what you want it to have when you're flying around. Right now, these robots can, you know, fly around, autopilot their way from one point to another, make decisions about whether they've got a signal and come back home and things, but not much more than that. So all the video you're capturing, they're just storing on board and processing later. But it's not going to be long before that video is being processed intelligently on board these aircraft, using, you know, more intense processors like the Snapdragon, so that you can have it go up and do things, you know. go under the bridge and find the bad joints and take pictures only of them, or go to the front edge of the fire and determine where it's going and decide where to fly next based on what you see. 5D Robotics is doing a lot of great sensing technology. Aerial Mob is some of our partners. They do a lot of drone-based filming. Brain Corporation has spun out of Qualcomm, and they're doing a lot of really cool kind of neuromorphic processing based on Snapdragon processors and stereo vision, and Vision Robotics, my old company, that's doing a lot of great stuff in agriculture. One last video. So these were shots that you could never get before. I mean, how could you video that guy doing that rock climbing unless you flew a crane out to the desert with these guys? So if you imagine all the cool stuff you do, all the great imaging you can do, and the great shots you can get, it's something that's really appealing. I'd like to say that's me, but so, thank you.